I'm Gill Verdon. I'm the founder and CEO of Extropic.
So what brings you to OODAcon?
Well, I've lived my whole life on a series of OODA loops, I guess, and I've discovered the concept, I guess, in the past several years. To me, I'm obviously interested in cybernetics and augmenting human ability to perceive, predict, and control our world at all scales. And that's what led to my career in physics-based AI and physics-based computing. Also want to get closer to the intelligence community and create some connective tissue with the government, given the technology that we're working on and its importance to all sorts of national interests.
Can you talk a little bit about the technology that you're working on and how it might intersect with those national interests?
Yeah, so we're trying to build the ultimate substrate for AI in terms of compute. We come from a background in kind of broader physics-based computing, previously in quantum computing at Alphabet, largely. And now we're building a stochastic form of computing. So that means a sort of computer that we can shape the output, and the output is somewhat random. And we can morph that output in order to do machine learning as a physical process. So I like to say we're building a steam engine for artificial intelligence, because we're doing AI as physics of electrons happening at very low power. So what does that mean practically? It means algorithms for artificial intelligence that are more probabilistic. They can quantify their uncertainty about things. They use far less data, far less parameters, and we use sort of compute that is inherent from nature, randomness that just happens because electrons jitter around. We leverage that in a clever way in order to get a massive speed up in time and a massive energy efficiency gain. So for us, we think it's the next evolution of computing, and it's the only way to extend Moore's law for the next 20 years and keep scaling AI compute now that we're sort of hitting a ceiling with all these data centers needing nuclear reactors and whatnot. Yeah.
And so how do you see that contributing to national security, to a more secure, innovative, sustainable future? How do you see that intersecting? What are you looking to achieve?
Yeah, we're bringing more intelligence per watt and more intelligence per nanosecond to every sector. So what does that mean for national security? Well, if we can predict whatever it is we want to predict patterns in our internally or externally, and then take the highest quality decisions given whatever data we have on hand, that's what this unlocks. This unlocks the highest quality decision making on a much faster time scale, and have intelligence, artificial intelligence, be far more ubiquitous because it requires far less power and is far denser. So ultimately, that means intelligence at the edge that has all sorts of defense applications, but even in the cloud, just higher quality probabilistic decision making on fast time scales and with uncertainty. So that's what our technology could unlock for the government sector.
What about direct impact on the OODA loop itself? You talked about at the beginning. You talked about your experience or knowledge of the OODA loop. How do you see your work impacting the OODA loop?
I mean, ideally we build machines that will, help us take faster cybernetic loops and kind of make higher frequency decisions for us, and then we can kind of supervise it on a longer time scale on a nested loop. And so we're creating a sort of cybernetic hierarchy where ideally we have AIs that are subordinate to humans, and these augment our capability to do whatever we'd like, really. So it's really a leverage for our human intelligence.
And in the work you're doing, how do you make sure that the AI remains mission focused and under human control, and kind of where in this hierarchy do you see that happening?
Yeah, the thing that's interesting about probabilistic algorithms is that they can show you their beliefs about any variables, and they're far more interpretable, these probabilistic models. They can kind of quantify their uncertainty about their predictions rather than you having to just listen to a model that sounds self-assured when sometimes they have no idea. And so actually it's going to improve sort of human readability and reliability by going this probabilistic route. But unfortunately, with today's compute, these probabilistic algorithms remain sort of out of practical reach because they're so expensive in terms of computation. But if we suddenly flood the market with far cheaper computation, then suddenly the algorithms will shift to adapt to this change, and that's our hope. Yeah.
Okay. Anything that I didn't ask about that you would like to add or discuss?
Yeah, I mean, just like I'm sort of bringing noise and entropy to computing, I think on the cultural front, encouraging variance, exploration, innovation, adaptability, not just of designing complex systems that are computers that are stochastic, but seeing our whole system, like America, and any sort of complex system that we have control over as a similar system, and bringing sort of thermodynamic computing thinking to every other system has been sort of the movement I've been leading with effective accelerationism, which is sort of physics-based perspective and policy prescriptions for various things, including what to do with AI to maintain our competitive edge over China. So our thesis is that maintaining a healthy startup ecosystem, collaboration between startups, that may mean some open source software, really gives us an advantage over centralized control of our adversaries, because we have far more speed, because variance equals speed for sort of this evolutionary search over the space of technologies. And so that's definitely affected policies over the past few years now, and it's been a very growing movement. So it's not just on the technology side. I've, I guess, had my hand in shaping culture upstream of policy for that.
Excellent.